Okay, thank you. Thanks everyone for showing up for the 2021 Remote Web Science and Digital Libraries Research Group Research Expo. We're trying this out new this year. Glad to see a lot of familiar faces here. So to start off, we're going to do a brief introduction from the faculty, and I'll go first. I'm Michael Nelson, and my research areas are web archiving, digital preservation, repository object interaction. I've been here at ODU forever, so most of you guys know me, and I won't take any more of your time talking about that. I will instead toss it to Dr. Michelle Weigel.
Hi, I'm Michelle Weigel, a professor at ODU. Just thinking about this, I just realized that Michael and I have been working together in the WSDL group for 10 years now.
Wow, yeah.
And so it's hard to believe it's been that long. My interests are in web science, archiving, of course, social media, and also data visualization. And we've been having fun digging into, archiving aspects recently of Twitter and Instagram. And that's been really interesting, all of the problems that have come up with that. And just real quick, I wanted to say a little bit about the work that Abigail is going to be presenting in a bit here. And the idea of the memento-aware web browser came from discussions with Herbert van de Sompel and Martin Klein and Michael. And it was an idea that I presented almost 3 years ago at Waddle. And it's still my pinned tweet. So I'm very excited that part of this idea is now a tangible thing that we can see. So thanks.
All right, excellent. So how about next, Dr. Sampath Jayaratne?
Hi all, I'm Dr. Sampath. I'm an assistant professor at ODU. So this is my third year at computer science. I joined back in 2018. So my research interests are in eye tracking, multimodal sensing, machine learning, and information retrieval. So we do a lot of research in eye tracking and EEG in the domain of physiological sensors, looking at some of the health domain, things like autism spectrum disorder, ADHD, PTSD, and using some of these devices to come up with objective measures. So I have 4 PhD students. Yasit going to be presenting some of his work, and then some of the work that Yasit is presenting today is what we got the NSF career recently. So it's a very interesting area that we are going towards. It's called real-time eye movement analysis. So he's presenting some of his recent work in this area, using metadata to kind of do real-time data analytics and replay. Very interesting, and probably you're going to enjoy the work. Other than that, we have a group working towards some of the ADHD domain and also PTSD. So we have Gavindya. All of them are kind of around second year, third year PhD students working on different projects. And I think we have 2 master students, 1 already graduated, and then a couple of freshman undergraduate students.
Okay, thank you. Next up, Dr. Jian Wu. Jian, are you there?
Yes, I'm here.
Okay.
Sorry, I was muted.
Yeah.
Yeah. Hello, everyone. Nice to see you. My name is Jian Wu. As you can see, I joined the ODU Web Science and Digital Library Research Group in 2018, the same year as Sampath. And my research interest includes scholarly big data, natural language processing, applied machine learning and deep learning, information retrieval. I'm involved with a multiple project, and one of the biggest ones was supported by NSF called CiteSeerX. So in case you don't know, CiteSeer is a digital library search engine serving more than 10 million academic documents. I'm collaborating with Dr. Celie Giles on this project for many years. Another project that I'm working on is supported by IMLS. I see that Karen Vaughan is here. She's in our advisory board. So in this project, we're developing machine learning and deep learning models to segment and summarize and classify electronic theses and dissertations. And this is the project I collaborate with Dr. Ed Fox and Bill Ingram in Virginia Tech. I'm also leading some other projects on outlining figures in US patent. So we're trying to build a search engine to search figures by looking at the semantic similarities between them. So I have 4 PhD students. So Sampath will present his work. He recently submitted a paper to JCDL, and he's going to present his work on extracting metadata from electronic theses and dissertations. And those are scanned, so it's more challenging than one digital ETDs. I have another student, Xinwei and Lamia and Kenny. They are also working on different projects. Thank you.
All right, thank you. And next up, we have Dr. Faryana Porsadar.
Good afternoon, everyone. I'm glad to see you all here. I will keep it very short. So I joined ODU CS department last fall in the middle of the pandemic, and I'm really happy to work with Wastel Group. And they are a fantastic supporting group. I'm so happy to join to the group. And I have my PhD from Texas A&M. And right now at ODU, I'm teaching undergrad courses as a lecturer. And I'm really happy to work with undergrad students. And one of my favorite things is to kind of encourage them to join to the research early in their academic years. And yeah, we are working on a few proposals for the department to work on this purpose. And I'm also developing one course for the coming fall for this purpose. And on the research side, my interests for the research are for digital libraries, social computing, web and data science, and also machine learning. Thank you so much again. And thank you, Dr. Nelson, to providing this expo. Thanks.
All right, thank you. I don't think I see Dr. Vikas Ashok here yet, so I'm going to jump out of order. I know that Frank McCown has to leave before the end of the session. And so Frank was our first PhD student. I just wanted to give Frank a chance to say hello to everyone. I don't think everyone's met him. Frank?
Hey, everybody. Yeah, Frank McCowan. So I was Michael Nelson's first PhD student. I'll show you a picture. This was us when we were young pups back in 2007. And I did my research on reconstructing websites from their web infrastructure. And it had to do with writing a web crawler that would crawl archives and other web repositories and bring those web pages back together. So since then, I'm a professor at Harding University out in Arkansas. I teach computer science here, and I don't have any PhD students. We're just purely undergrad, but I teach a variety of classes in web development and mobile application development. And I've written a couple of books with Zybooks. I don't know if you've heard of Zybooks, but they do online interactive books in computer science and engineering and math. And so I've written a few books with them and contributed on a few other books. And that's kind of where my main emphasis is right now. And I'm working on an Android application development book with Kotlin. So that's kind of my focus and where I'm at. And it's good to see some familiar faces and of course a lot of new faces as well.
Thanks, Frank. And for those of you who've taken CS 432, 532 Web Science, that course is based on Frank's original course design from, I don't know, a long time ago now, but we've been
That's right.
patching it along, keeping it going, but it's still a ton of Frank's original stuff.
That's
All right.
right. I'm teaching that in the fall too.
Oh, excellent.
So.
Yeah. So let me see, I'm going to stop the share. To get started, we're going to have Abigail Mabe, and we're going to see if she can share her screen. Abigail, you there?
Yep. Is my
Got it.
screen sharing? Is my audio good?
Yep, we got it.
All right, great.
All right. We'll go ahead and get started. Thank you.
All right, so hello everyone. My name is Abigail Mabe, and today I'm excited to talk about my master's project, which involves taking Google's open source web browser, Chromium, and extending it to be a Memento-aware web browser. So before I define a Memento-aware browser, I'd like to first define a memento. So a memento is an archive web page. The easiest way to view an archive web page is to go to a web archive, such as the Internet Archive's Wayback Machine. And from there, you can view mementos for all sorts of web pages. I have an example here on the right of a memento of MITRE.org all the way from 1997. So web archives do allow for very easy memento viewing. Typically, they try to show that clearly the page is not a live web page. They'll typically show the name of the web archive, like in the screenshot here, you can see Internet Archive Wayback Machine. And they'll also clearly show the date time that the page is from. So we can easily see that this MITRE page is from April 12th in 2010. However, although the web page is displaying all of this information, the web browser itself is not reacting to the fact that the page is an archive page or showing any new browser user interface elements because it's not a live web page. So mementos can also exist outside of archives. So what I have here is an example of a w3.org page. It's a memento since it's a revision of a past page. And if you look closely, you'll see that there is a date time that the page does say it's from April 8th, 2020. But this is a very difficult to locate date, and it's not clear that the page is archived. So it can easily be mistaken for a live web page. So now what is a memento-aware browser? A memento-aware browser is one that is able to detect that a page is archived and update the user interface to let the user know that they are no longer viewing the live web. A memento-aware browser would make it much easier to interact with web archives and mementos. So the browser should update to show the date time, just as it updates to show the security state of a web page. So how can the browser detect that the page is archived and not live? Well, one thing that it can't do in order to achieve this is look at the URL. So if we look at a URL of a memento from the Internet Archive's Wayback Machine, we'll see that it contains the original URL of the page, mitre.org. But if we look at a memento from PermaCC, we see it's just a hash. There is no original URL. So additionally, the Internet Archive's Wayback Machine URL does have a date time, which is very convenient, but again, PermaCC does not have a date time. It's just a hash. So there's no defined URL format for an archive web page. So what we can do to detect a memento is that archive web pages return the memento datetime HTTP response header. So we can look for this header in order to know if a page is archived. And since browsers already parse the response headers, we just have to additionally look for this one memento datetime header. So this header indicates that the response is a prior state of an original resource, and the value expressed by this header is the date time of that prior state. So if we do a curl request on a memento, we'll see that the memento datetime header is returned, and the value of that header is Monday, the 12th of April, 2010. And what we want the browser to do is, as it parses the response headers, we want it to read for that response header, read the date time, and display it to the user. So we can see that a memento icon is displayed to the user along with the date time. And we also want this to happen for mementos that are outside of web archives, just like this w3.org page. So is detecting archive content really this simple? And no, of course it's not. This is just one possibility. So not all web archives make the memento the root page. Instead, they're displaying the memento within an iframe that's on the root page. An example of this is the Australian Web Archive Trove. This is how they display their mementos. So what we have with this case is that the root URL does not return any memento datetime header at all. The root is a live web page. But if you inspect that page, find the iframe and find the iframe source URL and perform a curl request on that URL, that is when you will get a memento datetime returned. And we see that the page was archived in 2012. So how do we account for these iframe mementos that some archives can display? Well, we have to first think about the page structure within the Chromium web browser. So how is it actually processing this iframe that's on the root page? Well, a single tab in your web browser is known as an active entry. So the tab that you're currently looking at is the active entry. And this entry holds parameters for the entire tab and all elements on that page. For example, this security status is an HTTP web page, HTTPS, or a mix of both, and what message should be presented to the user about this security state. So essentially, the active entry consists of all information for all elements, all iframes and other embedded elements that are within that one page. So we can think of the page structure as a tree structure where the root node is the root web page. So the active entry also holds a tree of all rendered frames on the page. And a single HTTP insecure node could render the whole page considered insecure, and we would have to tell the user that there's a mix of secure and insecure content being displayed. So now we have to think about the Trove example in terms of an active entry. So if we have the single active tab, the Trove memento would show the root node, which is the root web page with no memento date time returned. And then on top of that root web page, it's displaying an iframe that shows a memento. So this memento iframe would be a child of the root web page with a depth of 1, and a memento date time is returned. So now we can relate this to a tree structure where the green node is the root web page and the purple node is the memento iframe node. So the memento OR browser will first process the root page as the root, and there will be no memento date time found. And then it will process the iframe node as a subframe, and a memento date time will be found. So now if you actually navigate to the Trove memento, you'll see that the iframe actually makes up the entire browser tab. So the scroll bar for the whole tab is actually a scroll bar for the iframe. So the iframe is being considered as the main active entry. So what happens with this is that the browser will process both the root and the iframe together, and the memento date time found from the iframe will be passed up to the root node because the iframe is making up the whole web page. So now we're considering the date time as the root's date time. And also the root node and the memento iframe node could have any number of their own child nodes, but this is for a future case. So what happens when we process the page this way and find the memento date time in the child node and pass it back up to the root is that the memento icon only pops up after the subframe has loaded and we have actually passed the parameters back up to the root node. So there is a delay when it comes to displaying the memento icon. A couple of examples of web archives that display their mementos in the same way within an iframe would be PermaCC and the UK Web Archive. So what about when there is a memento within an iframe displayed on the root page, but we don't want to actually consider the whole page as a memento? Well, for this, I created a test case where I made a live web page and I just put a memento iframe on that page. So the root node has no memento date time, and the memento iframe node with a depth of 1 does have a date time. So we can put this into the same tree structure as before, and it looks a lot like the Trove example, except for this case, we process the root as the root page and there's no memento date time found. And then after processing the memento iframe node as a subframe, we don't process the two together because the iframe is not becoming the whole active entry. Instead, we want to keep track of the fact that we found a date time on the page. So the root node still has a null memento date time because it is a live page, but now we have a list of memento dates that were found that exist on the page. So we know that the page has archived content, but the page itself we are not considering to be an archive page. So now the user is presented with a memento icon again to let them know that there is memento content presented, but we're saying it's mixed archival content. So there's a mix of live web content and archive content being displayed in that active entry. And the user can click on this and get a more detailed message, and they can also view the date time of the archive content that exists in the page. So what about pages with multiple mementos? So I created another test page where I put 3 memento iframes on the same live web page. So it's really similar to the example before, but there's more date times. So we have the root node with no date time, and then on that root page, there's 3 memento iframe nodes, each with their own date time. So all of these memento iframe nodes are direct children of the root. So just like before, the root web page is processed as the root. And then we process the 3 iframes as subframes. And when each one's processed, the date time for that frame will be found and added onto the list of memento dates that exist on the root. So now we have the same mixed archival content message as before, but instead of just displaying one memento date time in the pop-up, we display all 3 so the user can see all memento date times that were found on the page. So memento detection does go further than just one node down the tree. So both mementos and iframe mementos, for when the root page is a memento or if the iframe is a memento, they can all display their own render frames. So root pages and iframes can have their own number of any child nodes. And now frames within a memento should also be archived. However, the live web can actually display within a memento, usually by a rendered frame like an iframe, YouTube video, or some other embedded social media element. So with this, we have a memento that has a child node that is actually the live web. So we have the live web in a memento. So if I go back to a Trove memento, if you actually scroll down on this one I've been using as an example, you'll find an embedded Facebook element. So that Facebook element right now returns a 404. So the frame is blank. It does not count as the live web or a memento. So now let's go back to a time when this Facebook element actually still worked, and it actually displayed the live web Facebook within the memento. Well, this embedded element would allow for user interaction. It would show live updated content from Facebook within the 2012 memento. So we can call something like this a zombie in the web archive because it's a living dead memento. So if we add that on to our Trove example, and we assume that the root node's been processed, the iframe node has been processed, and the iframe date time has been passed back up to the root, and we look and see that the iframe memento now has a child node, which is the embedded Facebook element with a depth of 2 on the tree, we'll see it has a null memento date time. So we want the browser to detect this, that the memento with the date time is displaying a element without a date time. So when this happens, we want the user to be shown an icon that says memento plus live content. So we want to tell the user that there is live content in the memento they're viewing. So to sum up this memento detection, I've talked about when the entire active entry is considered a memento, we want to show the date time for that archive page. And I've also talked about when the active entry is a live web page that's also displaying some archived content within at least one frame or more. And also when the memento is displaying the live web. So how else can a browser be memento aware? Well, what I've talked about is when a user visits a web page, what can the browser do to be memento aware? But how else does a user interact with their web browser? Well, users also interact with their browser by saving bookmarks. So users bookmark pages that they want to visit again. Typically, the page contains some useful information that they want to see again at a later date. However, when you bookmark a page, that does not mean you can always visit that page. When you click on your bookmark in the browser, the page could lead to a 404, or the URL could lead to entirely different content. So what do we do when we want a page to always be there or always be somewhere where we can view it? We archive the page. So what I've implemented is a bookmark as archive feature. I essentially added a dropdown where when the user bookmarks a page and they open the edit bookmark pop-up, there's a dropdown where they can select an archive to submit the page that they bookmarked to. So they can click on the dropdown, and as of right now in the current implementation, they can select from Archive Today, Megalodon, and the Internet Archive. Since the browser is using Archive Now in order to submit the pages to an archive. So these are the three that work from the browser with Archive Now without an API key. So after the user selects their archive, they can just click the Done button and submit it. And what the browser does is it creates a folder for that entire URL. So for example, odu.edu. And within that folder, there will be a bookmark node that leads to the live page and an additional node that leads to the archive version. So there was an issue with implementing this. So bookmark operations run on the UI thread, which is why when you bookmark a page, it appears on your bookmarks bar instantly. However, archiving a page can take a while. It can take anywhere from 1 minute to maybe 10 or 15 minutes. So this runs on the background thread. Well, with the Chromium browser, you can't perform a UI thread bookmark operation on completion of a background thread operation. So I was not able to update the URL of the bookmark node once archiving was complete. So I implemented a workaround for this. So the Internet Archive and Archive Today have this nice URL format where given the host name of the archive, a 14-digit date time string, and the URL of the page you want to view, they will redirect to the closest memento they have for the given URL at the date time that you requested. So I can construct an archive bookmark URL without the page actually having completed archiving. So to walk through an example, if I were to submit example.com to Archive Today on March 10th, what would happen was initially my bookmark node would lead to the latest version of that page that Archive Today has. So right when I click the Done button and I submit to the archive from my browser, my bookmark node will link to February 28th because that's the closest date time they have to March 10th. After waiting a couple of minutes, once Archive Today has finished archiving example.com again, my URL will now link to the latest, which is on March 10th when I requested it. Additionally, I do print the URL to a file, archiveurls.txt, so if you want the actual URL, you could get that as well. But from the browser UI, it will be the constructed URL. So there is a lot of future implementation that can be done with the browser. To talk about the memento detection specifically, well, web pages don't have to be archived to return the memento date time response header. So this means that the browser would throw a false alert in the UI that it is a memento. So what we can do for this is we can give the browser a list of known web archives where the user can add or take away archives on their own local configuration file. So this way the browser would tell the user if there's a date time, but it's not from a known web archive. Additionally, the browser should identify temporally violative resources. So to sum it up, currently browsers do not identify archive pages. And the Memento or browser proof of concept features that I have completed are memento detection with the 3 possibilities. And I've added user interface elements to tell the user about this archive content. And I have additionally implemented the bookmark as archive feature with a workaround. So I do have a couple of YouTube videos demonstrating this that I can go ahead and show. audio. I have shared my audio, so it should come through when I play the video.
I don't think we're getting the audio.
I'm sorry, was that Dr. Nelson?
I don't think we're getting the audio, or at least I'm not getting the audio. You're right, you're muted now.
I'll reshare and make sure it went through.
I think there's an option on sharing screen. Show. Okay.
Yeah, I checked the box, so it should come through. In this video, I will demonstrate the memento detection feature of the Memento Aware browser. What I'm viewing in the browser is a memento from the Internet Archive's Wayback Machine, and I can see that the browser is displaying a memento icon along with the date time of that memento. I can additionally click on this and view more information about the memento, such as the exact date time. The browser will present the same user interface of the memento icon and the date time for other mementos from other web archives. Additionally, I can also view my test case of a live web page displaying a single iframe memento, and in this case, the browser will say there's a mix of live and archival content. Additionally, I can view mementos that are not within web archives, and the browser will present the same user interface of the memento icon and the date time. All right, so I also have a another video of the Bookmark as Archive feature. In this video, I will demonstrate the memento. In this video, I'm going to demonstrate the Bookmark as Archive feature for the Memento Aware browser. To use the feature, simply just click the star icon as you normally would to bookmark a page, and then select an archive from the drop-down. And then click the Done button to submit. Since I have submitted odu.edu to archive from the browser, I can now find a folder for the odu.edu URL on my bookmarks bar. Inside the folder is a bookmark node for the live odu.edu webpage and another one for the archive version. Selecting the archive version will take me to the Internet Archive's Wayback Machine, since this is the archive I selected. And from there, I can view the web page that I archived.
All right, excellent. So I know, let me see, it was Matt that had a question. Matt, you want to repeat the question?
Sure, yeah. I'm getting an echo. All right, whatever, I'll ask. Okay, so really interesting work, Abigail. I had a question where, say, oh, that's annoying. It's echoing on me.
I could turn my microphone down if that helps.
Or unshare the audio that you were getting?
Okay, all right, I think it's better now. Yeah, so really interesting work. Do you anticipate, how I should ask, how do you anticipate the changes needed to the UI if, say, a web page contained, for example, like 1,000 mementos? I know you had mentioned the mixed content, but for example, there's one site for the Internet Archive that hosts archive GIFs, and so each of those GIFs would have a memento date time, and so if you were to view that page, you would have, you know, a list of 1,000 different URIMs there.
You know, that UI definitely needs some work. That's something that was not considered because my main test case was my 3 memento iframe, mostly to get the back end working. So since the back end's working, the front end of actually displaying all those date times, that definitely needs work.
Yeah, I agree, but it's a really great work.
Thank you.
All right, other questions for Abigail?
I'm gonna
Hey,
quick question.
oh, I'll go after Jen.
Hi. Okay. I just have a quick question. So what's the computational overhead of detecting the mementos and showing everything to the user?
So it hasn't really added anything to the browser since it parses response headers anyways, and it's constantly working to update the security state icon. So if a iframe loads 10 minutes later and it's insecure, the lock icon would actually go away since it finally had that insecure content load. So the browser's already constantly doing these things, so it didn't really affect anything.
Okay. So it sounds is pretty fast.
Right.
Okay, thanks.
All right, there was somebody else. I didn't catch who that was. Is that you, Sean?
Hey, no,
No, he did.
I had a question. Hey, thanks. Yeah, this is fascinating work. It's thanks for presenting it, sharing it, and definitely going to Splunk in the GitHub repos. Some of the side effects of this type of these types of augmentations of browsers. Well, making changes to browsers is really hard, not just from an engineering perspective, but it's really large code bases. But from the social and standards perspective and that whole ecosystem, changing, getting the web itself to change takes a long time. What were some of the was there a gap here that you found that might be good input to give to browser vendors? Was there a particular small change or innocuous change or side effect of the questions you were asking that might be something that we could take to browser vendors and either ask them to offer as a extension API or a possible web standards change itself?
So I haven't put much thought into actually getting this out yet. Overall, what I've discovered is it's not much changes. Like, as I said before, the browser's already doing a lot of things necessary to do this. It's just very minimal code changes. But yeah, I think getting this actually out there and getting this on a browser would be awesome. What I have here is mostly a proof of concept. So a user can actually play around with this and be like, hey, this does make sense. This does enhance the user experience. But as for code changes, I found that it's minimal. So I think that it would work great with current browser implementations or being some extension that could be added on.
And maybe a follow-up question, is there a, if there was one API that was missing that would have made this much easier, what would that have been?
I didn't really need to work with anything like that. I just added another icon. If memento date time's there, added it. It's really minimal.
Thanks.
All right. Martin, did that answer your question?
Yeah, it certainly addressed that, and thank you, Abigail, for this incredible presentation. This is really cool work. Yeah, I was going in the direction as well. What could potential next steps be to try to lobby this to mainstream browsers to try to get their attention, basically, right? Because or whether you're aware of whether there's a protocol to follow to get to this point. We've seen this for Wikipedia and MediaWiki in general, that there's a process to follow, which is painful, but maybe it's worthwhile to look into that. Do you have a sense of how one would go about this? And is there maybe ways we could support this, or lobby, PR, all of the above, bribe the right people?
I'm not sure about the steps to take to get this actually added, especially with Chromium specifically, since that's what I did work on, because I believe Google, they're pretty open to a lot of changes, and they have a whole GitHub mirror for things like this where they could take issues and suggestions. But yeah, this is highly proof of concept. So I think what would be great is to actually get just people trying this out and thinking that, yeah, this memento icon, this makes sense, this is helpful. Or I actually know a lot of people who weren't even aware of archive web pages. So they're kind of thinking, well, why doesn't a browser do this already? So I think the main thing is just getting the word out about it.
So Martin, we tried to, we didn't want to scare her off by rehashing our experiences with MediaWiki folks.
Yeah, that was fun.
Cool.
that was exciting. I had a question. Let's see, with the bookmark as archive capability, let's see here. We're doing something similar in one of the projects I'm working on, and your workaround would be awesome for us. It's just that where are you actually constructing the memento URL, the URIM, based off of the URL that they're archiving?
Right, depending on which archive they pick. My workaround does not work for Megalodon, sadly, because they don't redirect to the closest date time. But yeah, depending on which one they pick is how I choose the host name.
And the other question is sometimes the Internet Archive, you submit things to it to save the page and it fails because they're having technical issues or whatever. Do you detect that at all?
So currently it does not detect that.
Okay, cool. All right. I was like, if you found a way around that, please let me know. All right, cool. Archive.is is great with that, but Internet Archive, they've got some issues. So, all right, thank you.
Okay, I'm going to say in the interest of time, we'll go ahead and wrap this up and see if we can get Drew started. Drew, you there?
Yes, sir.
All right.
I'll quickly share my screen. And all right, so are you able to view my screen?
Yep, we have it.
All right, awesome. So hello, everyone. My name is Dhruv Patel, and today I'll talk about what it looked like. This is a service for creating website time lapses using the Memento framework. Before we go ahead and get started, I would like to submit a time lapse request for coxautoinc.com by tweeting hashtag what do you look like and right after it coxautoinc.com. So I'll go ahead and tweet this, and hopefully by the time we get towards the end of our presentation, we'll have a result for this. All right. So I'll talk about the introduction and motivation behind this project, and as well as the overview of how this service works. And this was originally implemented by Dr. Alexander Nawala in 2015. I'll also talk about some of the improvements I've added to this project, as well as some future enhancements that could be benefited by this. All right, so the web has been around for quite some time, and the content shared on the web has grown significantly. In fact, since the year 2012, the web has almost doubled in size every year since then. The web is impermanent, which means that new content is constantly being added, or content is being taken down or even updated. So preserving this content of the past web is very valuable. And in order to visualize the changes a web page has gone through over time, a good way to do this is actually visualizing the transitions. So you may ask, how can we possibly view, how can a web page transition be captured in the first place? So our goal is to see the web page change over a long period of time. And a common way to view such changes is by using a time lapse. So how can we create a time lapse of a web page, you may ask? So this is where web archives come in. Web archives store billions of past web pages, and the largest web archive is the Internet Archive. A snapshot of a web page is referred to as a memento, and a collection of these mementos for a specific URL is known as a time map. So here we're looking at the first 700 mementos of apple.com spanning from 1997 to 2006. And we could see the first few mementos had quite a similar web page design for those first few mementos. And then we saw a change in the web page design. And to the human eye, this is very easy to view. However, how could we possibly view these transitions? So the transitions we're trying to view is something of this sort. So we have a memento of apple.com from 1997, 2010, and 2021, and we could see how significantly different these web pages are. So this is something we are hoping to view. So currently, apple.com will have has over 100,000 mementos. So how can we possibly sample from this many mementos? What's a method we could use? Well, there's a project called Time Map Visualization that does this by acquiring mementos that have changed significantly. We'll refer these significantly different mementos as unique. And in order to calculate these unique mementos, the TMViz program uses a sim hash technique. Pretty much a sim hash is calculated on a memento, and by a specified threshold, the memento is categorized unique or not. The only downfall to this method is the calculation is made on the HTML content of the memento. So this means there is some sort of overhead to actually obtaining the HTML content of this memento. Another way to do this, which is slightly faster, is by selecting the first memento from each year. And since we're looking at mementos from 1997 to 2006, that's 10 years for us. So we'll select 10 mementos in total, basically the first memento from each year. So let's look at closely to these selected mementos. So looking at these mementos, we could see for the first 3 years, the web page design was quite consistent. And then we see a change in the web page design for this. So putting all these snapshots together, we could create a nice shareable animation in the GIF format. So now you may ask, how do we choose which websites to make a time lapse of, and when would we make these time lapses? Well, the answer to your question is we don't. You, the user, tells us the websites whenever you think of them. So about 9 to 15% of accounts on Twitter are bots, and these bots interact with a large user base. Some of the examples of popular Twitter bots include Emoji Aquarium, which generates a random aquarium using emojis every few hours. And then we have Your Progress, which generates a progress bar indicating how much of the current year has elapsed. And finally, we've got another popular bot, which is the Netflix bot. This pretty much posts new movies and TV shows added to Netflix. So viewing this, this shows us that there's quite a bit of bots on Twitter, and users are aware of these bots. So we decided to make What Did It Look Like a Twitter bot. This would allow users to submit time-lapse requests, and it would issue progress notifications about where the time-lapse generation process is for their requested URL. And then finally, we'll share the generated time-lapse with the users. So now I'll talk about how this process works overall. So the first step is to actually you, the user, to submit a request. And this is done by tweeting hashtag what did it look like followed by the URL, just like I did earlier. And here's an example of a time-lapse request. And as you may notice, in this tweet, I have multiple URLs. So yes, the What Did It Look Like bot actually recognizes multiple URLs requested in the same tweet. You do not need to tweet separately for different time-lapse, for different URLs. Once the user has submitted their request by tweeting it, now we wait for the What Did It Look Like bot to execute. By default, this bot will execute every hour. So let's talk about what happens when this bot executes. Well, the first step is it crawls Twitter, and it crawls Twitter to look for new, pretty much the time-lapse request. And in order to do that, we use the Twitter API. The Twitter API allows us to stream tweets in real time, as well as provide a tweet filtering functionality. This functionality benefits us quite a bit because we only want to acquire the newer requests. We don't want to acquire the requests we have already processed. In addition to that, the API allows us to create content as well as engage with our users. Once we've acquired these time-lapse requests, our next step is to actually process these requests. Let me walk you through what I mean by processing the request. So all URLs shared on Twitter actually are wrapped in TCO links. And this is Twitter's URL shortener service. So as you can see in my example, we have tncc.edu, which actually points to a TCO link, and that TCO link redirects to the tncc.edu. So part of the processing request portion of this, we basically extract the URL that the user actually requested, not the TCO link. We want what the user requested. Once we have this link, we request for time maps for this requested URL. And in order to acquire the time maps for this URL, we use an external time map aggregator. We use Time Travel's do-it-yourself API. We simply provide the URL to this API, and in return, we get time map links to various web archives. Then using these time map links, we fetch mementos that are in these time maps. Once we have mementos from all these different web archives, our next step is to select mementos. So we use we use the original method, the method we talked about earlier of selecting one memento per year. So once we've selected these mementos, our next step is to create the visualization. So using these selected mementos, we load each selected memento inside of a headless web browser, and we take a screenshot, and then we put all these screenshots together into a nice shareable GIF format. And finally, once we have this visualization generated for us, we simply share it. So let me show you what it looks like. So this visualization is posted to Tumblr, to the What Did It Look Like, what It Look Like's Tumblr blog. And in order to post to Tumblr, we use PyTumblr, which is a Python wrapper for the Tumblr API. Once this post has been created, the next step is to notify the user who requested for this time lapse. The user is notified that their time lapse is now available, along with a link to the Tumblr post. In addition to that, the users who follow the What Did It Look Like account are also notified about a time lapse being available for them to view. So this is how this was the overall process walkthrough of the What Did It Look Like service of the original implementation. And now I would like to talk about some of the improvements that I have added to the service. So some of my improvements have consisted of updating the deprecated technologies used. As I mentioned earlier, this was implemented in the year 2015. So I have updated the service from Python 2 to Python 3, as well as the process of taking screenshots. So originally screenshots were taken using Phantom.js, which is currently a deprecated framework. Unmaintained framework. And I've updated this to use Puppeteer, which is maintained by Google. In addition to that, I have added features to the original service, such as diversified memento selection and updated visualizations. Let's talk more about the improved memento selection process. So users can now actually specify a date range for the time lapse. So you could specify the duration of the time lapse you'd like to view, and this would be requested in the year, month, day format. And in order to use this, we only require to know the year, and the user can be more specific if they would like to, and they could mix and match, such as in this example, I specified a from year followed by a year month. And if the user has requested multiple URLs with this date range, the date range will be applied to all those URLs. So some of our goals with this with this refined memento selection process was that we wanted to diversify selections by using mementos from different web archives. We wanted to include mementos from as many web archives as possible. And we also wanted to consider repeat requests when selecting mementos. So a time-lapse request for a URL could be requested again. The same URL could be requested again after a nomination differential. So think of the nomination differential as a cooldown period. By default, this is 30 days. So if a URL has been requested, this URL will process this URL again after 30 days. So what happens when we process this after 30 days? Our goal was to avoid selecting the same mementos we did the first time around. We wanted to create new content for this. So those are some of our goals. So our first step in this is to actually, once we acquire all our time maps from the various web archives, we sort these time maps by memento count from fewest mementos to most mementos. This is in order to give the smaller time maps a chance to select mementos from them, and then the holes would be filled in by the bigger time maps. The next step is to filter our mementos. So if the user had requested for a date range, we simply discard all mementos that do not fall into this date range, and we only include the mementos that are in that date range. Now let's talk about the actual selection process. So here we have 3 different time maps for a specific URL, and the time maps are separated by color, red, orange, and green. So let's look at the first time this URL is requested. We'll select the first memento from each year across these different time maps, and you can see we've been able to include all these. We've been able to include mementos from all these different time maps. Year 2 and year 5 were covered by time map number 1, and then year 1 and 3 were covered by time map number 2, and finally year 4 from time map number 3. Now let's consider this URL being requested again after 30 days. Well, in this scenario, we want to select the second memento from each date range. We want to select the second memento from each time map. And in this process, right before we select the memento, we check that each memento is valid. So pretty much we want to make sure that the memento does not return a 404. And in this process, we could actually see that we were able to select the second memento from each year from time map number 1. Time map number 2, we did not select the second memento from year 1 because it does not have one. So we decided to look for that from the third memento, from the third time map. And then for year 4, we actually selected the same memento we did the first time around. This is because if you notice, across all these 3 time maps, we only have one memento for that specific year. So except that, we have selected different mementos this second time around. Now, we also wanted to consider URL. We also wanted to consider URLs that are fairly new. Generally, these new URLs do not have that many mementos. So instead of selecting one memento per year, we select one memento per month in this specific case. And we pretty much follow the same process, whereby the first time this is requested, we'll select the first memento from each month, and then after that, the second time this memento is requested, we would select the second memento from each year and check for 404s as well before we select the memento. And if there's only one memento available across all months, across all time maps for a specific month, we'll select that memento again. Now I'd like to talk about some of the updates to the generated visualizations that I have added. First of all, the generated time lapse consists of a title slide. The title slide indicates the URL that the user requested for, and as well as the duration of the time lapse that they're about to view. In addition to that, I've also added translucent watermarks for the date time of that memento that they're viewing in the time lapse, as well as the archive that this memento belongs to. Next, instead of generating a GIF, we're now generating a video in the MP4 file format. And since MP4 file format supports audio, we actually select a soundtrack based off of the category of the URL. So let's talk more about the URL categorization. The URL categorization is based off of the content that's hosted on that specified URL. And in order to do this, we're using Wikipedia's categorization. So here's an example of the Old Dominion University's Wikipedia page. And we could see some of the categories is, the first category is Old Dominion University itself. And then we have public universities and colleges in Virginia and so on. So we're looking for keywords in these categories, such as we can see the first category has a keyword of university. So this indicates this belongs to education. So essentially we are categorizing Wikipedia's categories. Once we have categorized the web page, our next step is to select a soundtrack. And we select a genre. So each category has genres mapped to it. So looking at the previous example for Old Dominion University, which would be categorized as education, our genres that are relevant to this category is acoustic and jazz. So we would select a genre at random. So once we've selected one of these two genres, then we'll select a random music track that belongs to this genre. And on average, each genre has approximately 10 music tracks. And these music tracks are acquired from Bensound and Mixkit, which have royalty-free tracks. Once we've selected a music track, we then have a bit more randomization, which is to select a random starting point, and we just simply verify that the starting point to the end of that soundtrack is enough to cover our time lapse. So we verify that before we actually process with this new starting point, with this random starting point. And this generated MP4 is actually posted to the Tumblr blog page of what it'll look like. And the Tumblr API supports this with a few restrictions of the size being less than 100 megabytes and the time lapse being less than 5 minutes. And this is this is not much of an issue to us, as time lapses are generally short and quick. In addition to that, we have added a Instagram posting feature. So this time lapse is shared on what it look like Instagram account. So some of the content limitations of Instagram is Instagram, to begin with, does not support GIFs. If a user tries to upload a GIF, the GIFs are going to be converted into an image where only the first frame is uploaded. So our solution was, instead of uploading GIFs, we decided to create a video time lapse, as this is supported by Instagram. And some of the limitations of videos, some of the requirements is that the video needs to be more than 3 seconds and should have more than one frame. So we, in order to automate this process, we explored using the Instagram website. However, we later noticed that the Instagram website does not allow creating posts. However, the mobile site does. So what we attempted to do was simply change the user agent and to that of a smartphone, so we could automate this process of posting to Instagram. And we later discovered that since we are attempting to post a video, this can only be done using the Instagram app itself. So if we wanted to use the Instagram app, if we wanted to automate navigation, what we would need to do is we need to select elements in the Instagram app. And once we've selected elements, we would interact with them by simulating triggers, such as we would select this element of create a post and then simulate a touch trigger. So it would lead us to the next page, and then we could select the media we would like to share in next. So in order to select these elements, we need some sort of information about the element, such as a class name or an ID or an XPath or something like that. So let me talk about how I acquired this information. So in order to acquire this information, we used a utility called UI Automator Viewer, which comes with the Android Studio package. So basically what this utility does, it grabs the current XML dump of the current screen that is connected to the computer, and it will also take a screenshot. And this utility will nicely map each XML element to the screenshot. So here we could see the datetime widget that is selected, and we could see all information about it, such as the class name and so on. So this is enough information for us to select that element and then later on interact with it. So in order to automate this whole interaction process, we use a framework called Appium, which is a mobile interface navigation framework. And all interaction is done by via simulating triggers such as touching or long press and so on. Now, in addition to this, we're also using BrowserStack. BrowserStack allows us to avoid having a dedicated hardware device that is always connected to the computer that is running the What Did It Look Like service. So BrowserStack provides us access to a cloud-hosted mobile device, and most importantly, it supports the Appium framework. Some of the other updates we have is the response that is issued to the user. In addition to the Tumblr post, we also include a link to the Instagram post, and we include the time lapse, the time lapse itself in a GIF format to the user. These changes are also applied to the tweet that is intended for the followers of the What Did It Look Like account. Some of the future enhancements that could be added to this project is uploading this generated visualization to the currently popular platform of TikTok. Currently, there's no API functionality provided in order to do this. Another enhancement that could be added is a front-end system for analytics, which would create charts for us to view, to get insights to the types of URLs that are requested. And this would also, this front-end system could also host a way for us to monitor running processes, as this is kind of done manually as per right now. Another enhancement that could be added is to the Tumblr blog page. There is a search functionality that could be added, which would allow users to search for time lapses before they request for it. So they would first refer to this, they would first refer to the Tumblr blog before they request. And in summary, I have talked about how we could view transitions of a web page over time, as well as a service that could automatically fulfill user-submitted requests. And some of the major enhancements that have been added to this tool, of which are the date range feature, the new memento selection process, as well as updated visualizations that are shared to multiple platforms. And we could now look at our time-lapse request that we had requested for earlier, and it looks like our bot got our request. However, it just executed 6 minutes ago, so it's currently still processing it. However, we could look at a different request that I have made in the past, and I requested for Bitcoin.org as well as Ethereum.org, and I was issued a notification message that the bot had received my request for Ethereum, and then I had gotten that it had gotten my request for Bitcoin as well as Ethereum. And then later on, I was responded with the actual time lapse of this, and we have the link to the Tumblr blog page, which we could see here. And yeah, that's the random, I'm sure, were you guys able to hear the sound? So, I'm sorry, I can't hear you, Dr. Nelson.
Yeah, we heard it. Yep. Excellent.
Okay, awesome. And yeah, similar to this, the same time lapse is also posted to the Instagram account with the same audio. And this audio again is selected randomly based off of the category of that URL. Thank you very much.
Okay, excellent. Thank you. And reminder to everyone that the slides, the GitHub repos, everything are linked from the homepage that you had. So any questions for Dhruv? Any questions?
I do. Dhruv, could you go back to how the audio tracks are chosen?
Yes.
Are they just random, or is it, well, you did say something about some text analysis you were doing.
Yeah. Let me quickly, this right here, right?
Yeah.
Yeah. So essentially what we do is we use the Wikipedia's API. So given a URL, so in this example, we said, let's say the user requested for a time lapse of odu.edu. So we would simply use the Wikipedia API to grab the categories of the Wikipedia page for Old Dominion University. So simply we are querying odu.edu to Wikipedia and get its categories, and then we categorize Wikipedia's categories. So yeah.
So Dhruv, can you go to the next slide that shows the music genres to the categories?
Yeah, that was the thing I was intrigued by. So
This is pulled out of the air, right? So why is education, acoustic, and jazz? You know, it's just spreading it around a little bit, right? Yeah. So
okay, so does it just randomly pick something from jazz versus say country for travel, or okay, cool. All right. That makes sense.
Yeah, and obviously you could you know, redefine all that if you felt strongly that government should be acoustic instead of cinematic.
Yeah, exactly. I was just curious as to how far it went down. That's all.
Yeah. All right. Any other questions for Dhruv? Okay, in the interest of time, I think we'll go ahead and see if we can get, next we have Montefiore.
Yes, let me share my screen. Okay, you guys are able to see my screen, right? Okay.
All right, looks good.
Okay. All right. Hello, everyone. My name is Montefiore Hassan Chaudhary, and currently I'm a second-year PhD student in the Department of Computer Science at Old Dominion University. So I'm currently working with Dr. Jianu at Web Science and Digital Libraries Research Group. And today I'm going to talk about machine learning approach, which is a supervised learning approach with visual features to extract metadata from scanned electronic thesis and dissertations, ETDs. So ETDs actually represents a student has successfully met the key requirements of key requirements of the degree. So ETDs nowadays are generated by using computer software such as LaTeX or Microsoft Word, and those are called boundaries. Now it is prior to the 1997 and possibly after 1997 are scanned, and you can see some of the different templates that we are using for our research purpose. These are ETDs from MIT sample. This is from Stanford, and this is from University of Michigan. As you can see that we are trying to extracting this metadata field from the scanned cover page of ETDs, and the templates are different across different universities. So that became challenging for us to extract the metadata field. So previously we developed heuristic baseline model using regular expressions, and this model was based on 100 ETD samples, but it posed a strong baseline and our model achieved 39% to 97% accuracies for different metadata fields. But the limitation of this task is that this is rule-based method, and it's not going to perform well if we provide variant sets of data. So in this kind of study, we proposed a learning-based method such as conditional random field, and we extended our data set and incorporated visual features by extending the text-based features to the CRF model. So scanned EDDs or EDDs in general are very, very valuable for digital preservation and we want to make it accessible to readers, researchers, students, and librarians. And it contains domain knowledge and metadata that can be used for many digital library tasks, such as analyzing citation network, predicting research trends, and extracting the metadata, and then indexing them, and then building a scalable digital library search engines. Now, many state-of-the-art tools has been designed for extracting these metadata fields, such as Grobit, Sarmine, or Parsit, but this has been designed for bound digital documents. So for us, these are for us, we're using scan documents, and there's no such tool which would be able to extract these metadata fields, and it fails to extract metadata such as from scan documents such as scanned ETDs. So to extract this text, first of all, we have to extract text from the scanned PDFs, right? So one of the computer vision techniques we are using here, which is optical character recognition. And optical character recognition is challenging because, as you can see, it produces lots of noises when it extracts the text. So we have to do some couple of experiments in order to identify which OCR tool we can use for our research purpose. Also, there are some other challenges are that the image resolution is poor, and the scanned EDDs contains typewritten text, and obviously the imperfection of OCR technology. So there are many commercial-based tools, based OCR tools are available, such as OmniPage, Google Cloud OCR, or Abby Fine Reader, but they incur costs. And so therefore we adopted Tesseract OCR, an open source tool which can return output as a PDF, as a plain text, or a header HOCR file. So as you can see from this pipeline that we have applied GoScript to the scanned EDDs, and it produces the scanned images, and that would be then feed into the Tesseract OCR, and then Tesseract OCR would extract the text from the scanned cover page of EDDs. So we chose altogether 500 EDD data set. So previously we had 100 EDD samples, 50 from MIT and 50 from Virginia Tech. Now we have extended our data set by adding 400 EDDs from different US and non-US universities. So as you can see from this figure, distribution of metadata fields of the universities, these two bold regions are indicating our previous data set. And these are the newly added data set from different universities. And also we chose the ETDs from 1940 to 1990. And we have chosen both STEM and non-STEM majors. And these are from 468 doctoral, 27 masters, and 5 bachelor's degrees. So we derived 7 intermediate data sets from 500 ETD samples. So first of all, we have the cover page of ETD in PDF format, and then we applied GoScript to make it TIFF images. And then we apply the Tesseract OCR on that. That outputs the plain text, which is noisy. So it contains so many noises and misspelled words. So we have to clean them manually, and thus we have obtained text clean. And then for a research purpose, since we are using CRF model, we have to annotate the metadata fields. So we have annotated 7 metadata fields, and then we also downloaded the ground truth metadata, which has been provided by libraries, by the digital libraries. And these are in XML, JSON, and HTML format. And we had to revise this ground truth library metadata because there are some discrepancies between this library provided metadata and the data represented in the cover page. For example, chemistry has been defined as polymer or chemical engineering in the library provided metadata. So we had to visually inspect the PDF, scanned cover page of PDF, and then we created the ground truth revised version of this ground truth metadata. So so one of the method, this is the CRF model with sequential labeling, since this is a classification-based model. So we chose conditional random field by studying several other literatures, and this is kind of promising. And this model assumes that the features are dependent on each other, and it considers future observation when modeling a sequence. Now, we annotated fields and we encoded each annotated field by following the bio-tagging schema. Now, as you can see from this figure, that grammar for vision is the title field and Leon Garden Schumann is the author field. Now we would encode each of this word with following this bio schema, and this B is representing as beginning and I is representing the inside. So since grammar is at the beginning of the sentence, so we would encode this as B title and for as an I title and vision as an I title, since these are two inside of the sentence. And same goes for author. So we also tag each token with parser speech. Now, let's say our index is at Schumann. Now the parser speech for Schumann is noun, right? So so in our model feature, we would look at the previous two tokens, which is also a noun. And thus our CR model would identify that Leon Garden Schumann is the author field, and thus it's an author. So it would be identify the author field for this name. So these are the model features that we have chosen, whether all characters in the string is uppercase or lowercase, such as, for example, this one, we are looking for if all the characters are in the string are uppercase or lowercase. In here, we have seen that all characters are uppercase. Also, whether all the characters in the string are numeric, such as we have so many numeric values in the text, as well as like last three characters of the current word. For example, if we take Stephen, then we'll extract the last three characters from this word, and the last two characters of the current word. For example, we would extract en from this Stephen, which would be our last two characters of the current word. And obviously the post tag of the current word, for example, the Stephen would be the post tag parser speech, which is the Stephen is the parser speech is noun. And the last two characters of the parser speech tag of the current word, and whether the first character of the consecutive word is uppercase. So here you can see that the first character of these consecutive words are uppercase, right? So also, as well as like the Masters of Architecture, Massachusetts Institute of Technology, also here architecture. So here the first character is uppercase. So whether the first character is uppercase for the word that is not at the beginning or at the end of the document. So here, this institution field, also the degree field and also the program field is not at the beginning or at the end of the document. So it's inside. So we are considering the first character is uppercase for the word that is not at the beginning or at the end of the document. So for our further study of the CRF model, we were interested in learning visual information. So we know that the heuristic model is rule-based and it's based on the text-based features. Also, as well as the CRF with sequential labeling are also rely on the text-based features. Now, when annotating the documents, humans not only rely on the text, but also it relies on the visual features. For example, when we look at the document, the title and the author field is at the top of the page, and whereas the advisor or university field at the bottom half of the page, right? So we are interested where exactly the title field appears or author field appears. So visual information gives us the corner coordinates of the bounding box of a text span, and this information is available from HOCR files, which is kind of a XML file. So as you can see from here, aspects is our token. We are measuring for this token, we are measuring the x1, y1, x2, and y2 coordinates for that and this is the coordinate values. So we chose the left margin X1 as a feature for all tokens in the same line for this visual feature, and the upper left corner Y2 as a feature for all tokens, and the Y1 as a feature for all tokens, which is the bottom right corner. These features have been normalized between 0 and 1. And these pictures is showing us that the coordinates of the bounding box of a text span. Here you can see that an experimental investigation of, this is a sentence, and we have the coordinates value for this sentence. Now the challenges is that since we apply the test direct OCR and we get the HOCR file, now this position information is available in the HOCR file for the noisy text. So this is the noisy text, which is OCR text. But since we applied the CRF model on the clean text, so the position information would be different, right? So this is where we had the challenge, and we had to align them so that the position information would be same. So so what we did that for text alignment purpose, we use the longest common sequence approach. This approach has been applied in various fields, such as bioinformatics field, and we are using edlib, which is a Python wrapper, and it would do the and it computes the similarity and minimum edit distance between two text sequences. And this is how we have obtained the text alignment, and then we map the positions for each token from text OCR to text clean. So now that we have implemented all our features, we are ready for the evaluation part. So we divided the samples into two sets, 350 samples for training and 150 for testing. So CRF model predicts the levels for each metadata field at the token level. However, what I meant that, so it would determine thermo as a B title, whether or not thermo has a B title or I title, or fluid as a B title or I title. So it's predicting at the token level, not at the sentence level, right? So, but whereas when we try to evaluate this whole sentence against the ground truth provided metadata, we have to come up with a way that we must glue the predicted tokens for each metadata fields and compare them against the corresponding ground truth metadata and ground truth revised metadata. So while comparing this title field against the ground truth metadata and ground truth revised metadata, a fraction of the predicted title did not match due to punctuation mark or space. So these small offsets are not caused by the model, and it should not be counted as a true positive, and it should be counted as a true positive. So what we did that we use a fuzzy matching algorithm, which is based on Levenstein distance, and it provides us all sorts of permutations like substitution, insertion, or deletion. And we set a similarity ratio to 0.95. And thus it would return the output as 0 and 1, whether or not it's a match or not match. So the CRF with visual features outperformed our previous models, as you can see from this figure, that it outperformed the heuristic baseline, also as well as the CRF with sequential baseline, sequential labeling, and the CRF with, and this is the CRF with visual feature. So from this table, we can see that the heuristic baseline achieved on the 500 data sets from 5% to 62% accuracies, F1 measure, and the CRF with sequential labeling has achieved 80.6% to 94% F1 measure, and CRF with visual performance, CRF with visual, it achieved 96% from 96% to 81.3% to 96% of F1 measure. So we can clearly see that CRF with visual, it outperformed all the previous models. So in summary, CRF with visual features achieved 81.3 to 96% F1 measure on 7 metadata fields, and we have observed that CRF with visual feature outperformed our heuristic baseline method and CRF with sequential labeling. And although model has been trained and tested on rectified data, it reflects the performance when the model will be used on real world data. So in future, since we rectify the text, noisy tesseract OCR text manually, so we will add post-OCR error detection and correction to our model to train and test on the real data. And we will fine-tune the current model by adding pre-trained language models such as BART and use bidirectional LSTM CRF to extract 7 metadata fields. Thank you. If you have any questions, please feel free to ask. I would love to answer.
All right, thank you, Montpierre. Sean, you had a question?
Yes, I think you might have answered it when you were talking about the different challenges with applying the visual features to looking at the text that was extracted, but I might have missed it. I remember struggling through using Tesseract several years ago, and I was looking at somebody's work on applying spell checking and grammar checking and things like that as a way to flag particularly problematic text. I was wondering if you guys used any of that.
Yes, so I have developed only for post-OCR error detection part, but we are still working on the post-OCR error correction part. So in the summer, I have a plan to edit that model to our current CRF model.
So Sean, let me add a few things about this. Thanks for asking this question. It's a great question. So our current paper focused on developing the algorithm and training the model. So we want our gold standard to be absolutely correct. Then that's why we want humans to do the annotation. And it's only about 500. So it's not a like humongous amount of work or something like that. So it's doable within a reasonable amount of time. When we are implementing this algorithm into the real deployment, and that's the time when we need to use some automated post-OCR correction. So we're trying to minimize the errors caused by the OCR. Of course, I mean, if we just, when we deploy everything to a real production machine, production service, the precision and recall may not be that good because of the noise coming from the OCR. But adding additional layer for the error corrections will definitely help.
Okay, cool. I'm really interested to see where you go with this because because of my own experiences with OCR, and I think that there's a lot of applications like this that, you know, it could be explored. So I appreciate it. Thanks.
Thank you.
Montpierre, I had a question. I know it's only 500 items in your data set. I was wondering, is there a particular university template or time period that is especially bad or good? I mean, is it just as you go further back in time, the typeface decreases, or the condition of the paper when it was scanned perhaps is in a worse condition?
Yeah, I have seen mostly from 1960 to 1970s, and these are from MIT's data sets. So those are the EDD samples that I had really need to work on, and it produced, and Tesseract OCR performed very poor on those data sets, rather than the EDD data sets which have been chosen from 1980 to 1990.
All right, thank you. And so Martin just posted something in the chat, potentially relevant work here. Martin, you want to say something about this?
Sure, happy to. So Miriam had, I believe, even won a JCL Best Paper Award on her work on OCR quality analysis of, I believe, old newspapers in the Netherlands, if I recall correctly. So this might be relevant. It's really good work, and Miriam is awesome. So that's maybe worth checking out.
Thank you.
I have a question.
Okay.
So, Mantabir, so we talked about post OCR processing. What about, before you do OCR, like prepping the image? So that I think is more useful for Tesseract, because Tesseract, doesn't do well on poor images. So typically,
Yes. So in that case, I have kind of, so our image resolution was poor. So we had to come up with a way that what format of the image would be suitable for Tesseract OCR. And I have converted into PNG format, as well as the TIFF format and also the JPEG format. And I found that the TIFF format is more suitable. When I applied the Tesseract OCR on TIFF format, it was able to extract the text. And whereas when I applied the Tesseract OCR on the PNG format, a lot of the text was missing. So
no, even in the format, I'm talking about, image processing before you feed it to Tesseract, something like erosion or, something that increases the sharpness and thickness of the text so that it's easier for Tesseract to identify the letters and the words properly, right? So
yeah.
these are several techniques that exist. And I think these are something that's automatically done by other commercial OCRs such as Abby. And I think Abby even has these post-processing NLP methods such as, using language models to figure out what's the likely word that, image corresponds to, not just the visual features that it sees, but also the language contextual features like surrounding text and all that. So I think
Okay.
there is that. And you use just OCR, right? For everything. You don't use the layout analysis tools, correct?
Correct.
So did you try any layout analysis tools? Basically, the ones that are specifically geared towards identifying segments or chunks of text in
So
an
that's our
image?
next task.
Yeah, because if you do that, you have smaller portions of text that you need to focus on, and then you can feed these individual portions to Tesseract,
Yes,
right? You can
that's correct.
prepare it well, like pre-process it, and then feed it. So less content, likely to increase accuracy. Of course, it cannot be too small. If it's too small, then also Tesseract doesn't do well in my experience. So, but breaking up the big image into smaller images, relevant images, before feeding it to OCR, right, can help significantly improve.
Thanks, Vikas, for the suggestions. For the pre-OCR processing, I was actually having this idea at the very beginning of this project. I was thinking about evaluating the OCR results by adjusting the brightness or the contrast of the input image. But for some reason that the idea was not implemented.
Yeah, those are very simple. Like for Tesseract, it's like 5-6 lines of code. You have to tinker with it a little bit to choose the right amount of all these things, contrast, all those things. You tinker with it, and those are the parameters that tend to improve your Tesseract OCR. I mean, I have personally experienced this not so long ago, wherein I had to do some invoice processing using
Right,
Tesseract.
but the problem is that the ETDs come from different places, so it's very hard to come up with a hard-coded threshold.
No, it doesn't have to be hard coded. It can be, even our invoices are from multiple companies, right? So they don't follow the same template and they have different resolutions. So this is just some kind of standard things wherein you just try to increase the sharpness and thickness of the textual content. So basically there is text and then there is non-text, right? So you want the text to be much more clearer. So there are some general pre-processing techniques that you can find several of them available online that you can use. They're just standard heuristics-based techniques that kind of amplify the textual content over non-textual content. Make it more
Right.
suitable for OCR.
Right. Yeah, that's good suggestion. Thank you. And for the layout analysis, I was investigating some layout analysis tools, but all of them are, there's no one that's a target for electronic thesis and dissertations.
There is layout analysis tools for, there are layout analysis tools for scientific documents such as papers. So
Yes.
probably you can adapt it sort of, in the sense, the recent ones typically that use regional CNNs and all that RCNNs, they probably can be retrained with electronics. I mean, electronic thesis documents are sort of similar to scientific papers, right? I mean, not exactly, but sort of similar. So probably some kind of transfer learning or some adaptation of the algorithm itself. A lot of things probably can be borrowed from that literature.
Yeah, we'll definitely try them. I mean, but we have a limited number of training data, so whether it works for a while or not, it takes an extensive amount of time.
I mean, you can probably not use one of those deep learning methods because they require a lot of data, but you can go for traditional machine learning methods, I think.
Yeah.
I'm going to jump in, and in the interest of time, I'm going to close this one out, and so we can move on to Yasith.
Okay.
Yeah. All right. Let me.
Thank you, Montefiore. All right.
Let me share my screen. Can you see my screen?
Yes, thank you.
Okay. So hello, everyone. My name is Yasith, and today I'm going to present you my research, which is on restreaming and synthesis for real-time analysis. So I'm going to start by saying that doing research is not easy. So let me explain. So ideally, a research should happen according to a manner it's given on the image on the right. So initially, you identify some research area by searching through the literature and figuring out something that's missing or something where you find some problems that you might improve. And then design a research study to see if you can do things better. Then you carry out some research to test the idea out, analyze those results, and see whether it actually solves the problem. And if it solves the problem, yeah, now you can go ahead and publish that. And still, if it doesn't solve the problem, now you have some experience and you know that maybe it was a bad idea to choose that kind of study. But in reality, it's not that simple. A lot of problems happen. So here I've included two images that I found on the internet. So these two images highlight key problems that are on doing a research process in reality. So the image on the left shows a scenario where a new researcher joins a research group and is given a task where some other researcher has worked on a few years back, and now he's trying to rerun that code. So here he's asking whether there are instructions on how to use it. No. Whether the code is commented, maybe not. And nobody knows where the files are. So given this kind of scenario, it's pretty hard to try and reuse some existing code for you to run some analysis. And the image on the right shows another problem. So here, when somebody explains a workflow, or when you have a documentation that explains some workflow that you applied on data, you might encounter some places where you are not clear how the researchers did that kind of applied some kind of transformations on the data. It's almost as if some miracle has occurred at that point. So these problems can be explained in terms of how reusing the data means. So the first one is the problem of where are the instructions on how to execute and how to actually execute some code. Next, you can talk about reproducibility, where you want to ensure that every time you run some code, you want to get the same result. And if you run it twice, if you get two different results, that's not like an ideal scenario. And you want to know, you want to have an explanation how you got that result, and you need to be able to verify the results that you got in the first place. So how do you ensure reusability and reproducibility of data? So when it comes to reusability, you might get away with having good documentations on how to use it and add some comments on the hard to understand parts of your code. And in terms of reproducibility, you need to document the research process. Ideally, this should be done using some visual mechanisms like flowcharts and pseudocode, so that anybody who is new may be able to easily understand instead of deep diving into the code. And you want to make sure that you implement this as a set of small tasks, not like one file that has like 5,000 lines of code. It's going to be tough to try and understand about that. does actually. And if there are some tools out there, you want to ideally reuse them instead of try and reinventing the wheel. So if you think about it, this is quite a lot of work. So especially when you're doing some research, you want to focus more on the research than doing all this stuff in the first place. So here you want, instead of doing documentations, comments, and documenting the research process and things like that, you want to try and focus more on the research because this consumes a lot of time. So how can you make this easier for a researcher? So when it comes to documentation, you could use metadata here. So I've included an image on the right, which shows a sample metadata from our work. So here you can see that it contains some keys and values. So here it talks about a device. And here you can see it talks about an eye tracker called Toby and having a model name Pro X260. And also you can see that it has different kinds of streams. And here it has a gaze stream and a pupil stream. So just by looking at this metadata, you can try and get a good idea of what are we talking about using this metadata. And when it comes to documenting the research process, ideally you should be using some visualizations to make it easy to understand. So here, if you are using flowcharts, and here you can use that flowcharts to make very nice visualizations of how your code actually runs. And if you think about flowcharts, if you can actually run these flowcharts that you generate, that will make things much easier from a development perspective. So here I've included two images. So the first one is a workflow designed using a visual programming tool called Node-RED. And an image on the bottom is one using a tool called Arrange. So here, just by looking at how data flows from one element to another, you can get an idea of how data is actually processed in this manner. And when it comes to like using code commands and implementing things as a set of small tasks and reusing things that's already out there, you can benefit from using something like scientific workflows. So the Node-RED and Arrange are also examples of some scientific workflows, but two major scientific workflows that are used among research organizations and institutions alike is Kepler and Pegasus. So the value of scientific workflows is that these softwares can be used to run things on hundreds of computers to make code run faster. So for instance, I'm sure you heard of this news back in 2019, where scientists captured the first image of a black hole. So here, this image was actually generated by stitching millions of images taken by Event Horizon Telescope and NASA. And those images were actually stitched like you stitch an image by taking a panorama from your phone. Only difference was that there were millions of photos in here. And in here, they used a scientific workflow called Kepler, the one I've showed here. And as you can see, these workflows have immense applications. And ideally, if there is a way to combine metadata and visual programming and metadata, visual programming, and scientific workflows together, that's what we actually did in our work. So here we propose Streaming Hub. So here we combine metadata for data sets and data streams, and we try to make scientific workflows reusable and reproducible. And we did some visual programming so that we can build the workflows, and we showed some interactive visualization dashboards using it. So here, this image is an example of a dashboard, and this image shows the architecture of Streaming Hub, which I'm going to highlight on the next slide. So here, Streaming Hub has 4 key components. So the first component is the dataset file system, which is obviously adding the metadata into the data. So here, we created the metadata schema, and we generated metadata for 2 different types of data. The first type is data sets, and the second type is data sources. So by data sets, I mean the data that's already stored on a disk or some server. And when getting these data, what we did was we added these metadata into the data stream, and we send them as a unified source of data. And we did the same for the data sources. The only difference here is that this data is coming from sensors in real time. And next, we implemented a data mux, where we receive these data streams from data sources and data sets, and we combine them into one unified stream of data. So here, Two images shown here shows some files that were created for data sources and data sets. So for data sources, you can see that it has 3 JSON files here for different sources of data. And also we have a Python script which actually creates the data stream from this metadata. And on the right, we have how we replay data sets. So here we have all the data of a data set included in a folder and a metadata file that describes this data set. And also we have a script which actually does the part where we replay the data. Next, we have the workflow designer, where we actually drag and drop elements from like a set of like drag and drop widgets onto a canvas and wire them together to build these workflows. So the good thing here is that the elements that you drag and drop have some logic already implemented inside of it. And when you connect 2 different nodes, the output of one node flows as an input to another node. So even though it's a very nice visualization, you can actually run some code by using this. Next, we have the visualization dashboard, where we can visualize whatever analytics we get in real time. So in here, you see like there are 4 streams selected on this particular screenshot. And on the left, you have like options to select different streams and subscribe to them. And in the center, you have different forms of visualizations, which depending on what your need is, you can like tweak it and make some different forms of visualizations. So we applied Streaming Hub for 2 case studies. So the first case study was for eye movement analysis, and the next one is for weather analysis. So in eye movement analysis, we did some eye movement specific analytics and tried to see if we can visualize data in real time. And for the weather analysis, we did some statistical analysis, and we wanted to visualize how different aspects of weather changed over time. So why we chose these 2 case studies was because they were from different domains and were used for different applications. And we used these case studies to answer 3 questions. So the first question was whether we can replay existing data sets using metadata, and whether we can build domain-specific workflows using them, and whether we can make domain-specific visualizations from them. So when it comes to the eye movement analysis, we use 2 data sets called NBAC and ADHD SYN. So the NBAC dataset contained XY gaze position data at 1000 Hertz, and the ADHD SYN one contained the same data at 60 Hertz. So we use these to replay eye movement data and obtain some eye movement specific analytics, and to synthesize eye movement data from analytics, and to visualize eye movement data outputs that are generated from the original data stream and the analytics. So here you see the screenshot of the workflow that was built to actually run this analysis. So here you can see different UI elements, and you have like element to select the streams, and then whatever data is coming from the stream, it's sent into different nodes, which actually does some kinds of processing, and it ends up in a visualization nodes. So these like images show correspond to visualization nodes. And based on that, this is the output of the operations dashboard once you actually deploy this workflow. So here these visualizations are generated in real time, and the image on the top shows the actual algorithm for the eye movement analysis workflow in the form of pseudocode. And I'm sure you'd agree that trying to visualize it in this manner is much easier than trying to process it by reading this text. So next, we had the weather analysis scenario. So here we used a data set called Fantasy Climate Change, which consisted of weather data from 49 cities across 36 states. So this data contained temperature, dew point, humidity, and wind speed data, which change over time. So we replayed the weather data from different states and cities, and we calculated the moving average analytics in this scenario, and we visualized that analytics through charts. So similar to the earlier analysis, we have another visual workflow that we designed using Node-RED, and here you have the UI elements, but the other parts of the workflow is specific to the weather analysis. So we have like the stream selector, and then whatever data is coming through is routed based on the type of data, and then the mean, the moving average is calculated, and it's visualized on the dashboard. So once you deploy it, again, you have a visualization similar to this, and you have the ability to select streams on the left and to see what streams you are currently visualizing, and to have the visualization on the center. And similar to the early one, I've included the algorithm, and I'm sure you'd still agree that trying to see it in this way is easier than trying to read through the algorithm here. So in the future, we plan to make these domain-specific flows publicly available for reuse, and also try to improve the communications mechanisms on Streaming Hub. And also we want to conduct an expert interview to gather user opinion, in addition to the domains of eye movement analysis and weather analysis. And also we want to support distributed execution of code on Streaming Hub, so that we can scale it up to like hundreds of computers, similar to how other scientific workflows do this. So I've added a short demo video here, and I'm gonna pause it like step by step so that I can explain some things. So here, this metadata file shows an example of a dataset metadata. So here you can see you have like authors, fields of that data, and you have different groups of that data, which says that you can break down the data by city and by state and things like that. And you have a link to the resolver script, which is actually the Python script that is executed to stream the data. And next, I'm going to show you the example of a data source metadata for the same scenario. So here, the data source contains a set of different fields, which corresponds to what kind of data is actually in this data stream. And it highlights the different names of the streams and whatever channels that they contain within it. And of course, the frequency that the data should be streamed at. And next, I'm going to show you like how I actually created, like replayed this data. So I was basically running a Python script here, and it actually spawned all those data streams just by reading these metadata and by resolving the Python script that should be run and actually streaming the data from here. Next, I'm going to show the workflow. So here, this workflow was designed using Node-RED. And as you can see, like I'm looking at the stream selector node right now, and that node itself is another workflow. So in this manner, you can nest workflows. So for instance, if you build some like simple workflow to do a particular task, you can like wrap that in another node and use that node in subsequent workflows. So that architecture gives some flexibility in how you design like research processes. And like the other types of nodes are configuration nodes. So here, these nodes are provided by Node-RED, provided on Node-RED by default. And you can do different kinds of things such as routing messages on the topic. So this is entirely event-driven. And we want to leverage that event-driven architecture to build different kinds of workflows. So now I'm going to go to the operations dashboard and see what are the streams that are available right now. And because I started that Python script, now I'm going to see different set of streams that are available. And now I'm going to subscribe to a few of them. So basically, I'm going to select the ones that should appear on this chart, just a few, and I'm going to subscribe to them. And once I subscribe to them, now the data is started streaming real time into the visualization dashboard. And now if we go back to the Python script and see what's the data that is actually being sent, so you can see that different kinds of data is being replayed by just looking at the logs. So the key takeaways of this presentation is that Streaming Hub improves the reusability and reproducibility of research. And we propose two things. One's a metadata standard. The other one is using that metadata standard on a visual front end to build workflows and dashboards. Then we use two case studies to show how useful Streaming Hub is, specifically eye movement analysis and weather analysis. And we showed that Streaming Hub greatly simplified the research process here, and we could replay data to generate reproducible results. And in the future, we plan to create a public repository of reusable workflows and try to improve the communication mechanisms and add support for distributed execution. So if you're interested in looking at the source code and if you want the link to the slides, I've added the links below. And thank you so much for listening to my presentation. And I would love to have questions.
All right, thank you, Yasith. Questions for Yasith? John, Shirley, you have a question?
Well, so yeah, I was trying to form the question. I want to play with this. Is this available, or is this still in development, kind of?
There's the like initial prototype is available, but it's like spread across 3 projects. I can share you the links. So you need to like get all the projects and run some make commands to get it running, but it's possible. Yeah.
Okay, and so you showed the eye tracking data and also the weather data. Shoot, I guess I'll go ahead and wait for that and see what other questions I have after that. There's a lot of potential here.
Thank you.
So certainly choosing those 2 domains, I mean, they're very different and they illustrate the generality of your tool. What other domains do you think would be applicable? Not that you're signing up to do them, but what other domains do you think?
So based on the tools and the structure that we use, I think any form of data that has like a temporal aspect to it. So it's like some observations changing over time. If the form of data is in that manner, I think it could be used to send the data and do some analysis using it. Because everything here is like based on how things change over time. So that time aspect is important. And I think any data set with like a temporal aspect can be used to build analysis workflows. But we of course need to like do some studies and see if, like how well it does in practice.
Is there an IoT application in here?
Yeah. So actually the Node-RED is built for like IoT applications. So we were just like piggybacking on that and trying to use it for like sensory data or like trying to replay existing data.
Okay.
I mean, initially my thought was, how do I hook this up to Web Archive? And then I was going down the path of, well, what does that mean? And so that's why I was struggling with my initial question, because it needs to have some more beef to it. But I think there's a lot of potential here for a lot of different things.
So that's a good point, Sean. Like, I spoke with like Yasit about this idea, like, when we were thinking about the JCDL earlier, whether can we use kind of memento and maybe a way that, because if there is a kind of a temporal aspect, right, there are these mementos kind of generated and stored, and can we replay them and how we're going to be using it? Like, especially this is important, is like, why this is important, because when it comes to real-time processing, that's where this is important, because whenever we are designing things, we don't have a way to sort of like replay things existing. And so we need to kind of go and figure out how we're going to replay these so that we can use them to kind of design some real-time system. So one example is that right now, Gavin, my other student, she's working on something called real-time pupillometry. So she needs to kind of simulate real-time data. So the only way to do it is through Yasit's code, so that existing data that you can simulate like in a real time. So she can test her work until she because we have the offline pupillometry measure, but we don't have a way to figure out how this is going to look like when things run in real time. Right? So you can only way that you can do it is generate something real time, or you need to simulate it. So when you want to simulate it, that's where this work going to be really, really important, because now that you can test any data set that you can run through it and simulate it.
I mean, I was also thinking like even logging analysis or something like that, because that's just sampling. I mean, there's, yeah, I like to continue the conversation once I've thought about it some more.
All right. So we've got one more presentation to get to. Let me see, Javadul, you ready?
Sure, Professor.
All right, thank you, Asif.
You're welcome.
Can you? Sorry, can you see the screen?
Yes, Javadul, we've got it. Thank you.
Good afternoon, everyone. I'm MD Javadul Firdaus, one of the PhD student here in the computer science department. As we are going through one of the challenging times of our lifetime, some people experience a lot worse than that, especially if you are not able to see, because they don't have access to visual information from both outside and the virtual world. And to access this, they have to rely on assistive technology like screen readers. Today, I would like to share with you our works which mostly focus on those screen reader users to assist their online experience. Seeing this world with both of your eyes is a blessing, but not everyone is fortunate to have this. If you're seeing this slide, then you are the part of the one of the majority group who can able to see, because according to the report of Visual Impairment Blindness Statistics 2020, about 39 million people are blind users throughout the world, and among them, the United States placed in the top 4 position in having blind people. These people have to rely mostly on the air to perceive action from the world. A screen reader is a special type of tool for these people, which is to narrate every content on the computer. But using a screen reader is not always easy for them because it works linearly, which means it will navigate to top, down, and left, right direction. So if you miss one of section, then you have to go over the whole pages and come back to the same position that you are looking for. Beside it, you have to listen to every element of a web page to operate, which kind of painful for a person who are using this technology for a long time. Existing research is mostly based on either web annotation assistant and or web automation, although web automation indeed reduce the manual effort of screen reader user. They are currently limited to supporting a few frequently performed repeated tasks. They do not provided any support in ad hoc web browsing scenarios involving arbitrary websites. Researchers have also proposed accessibility assistant for assisting blind users to efficiently interact with web pages using a natural language or special input capture, and web annotation involves in human training. One-size-fits-all solution rely on either specified ontologies or pre-trained heuristic model. Therefore, these techniques cannot accommodate the fine-grained website-specific personal interaction needs of screen reader user. Having this issue, we introduce a hashtag, a browser extension with this blind screen reader user can create their own custom developed content for any arbitrary web pages. Especially, the user can leverage hashtag provided keyboard shortcut or reprogram mouse action to explicitly tag desired segment, like search result filter option form menus are shown in the figure. And this hashtag will automatically generate and add the corresponding skip link for these segments to the custom developed content for their web pages. This way, any subsequent access to this tag segment can be done quickly, directly by accessing the developed content instead of relying on the tedious manual screen reader navigation. To identify the semantically meaningful segment on a web page, hashtag leverages existing data extraction algorithm, but before this, a blind user uses a screen reader by using a specific shortcut from any modalities to enable a step from a browser. By doing this, it will establish a communication between the user and the web content. As excuse me. Sorry. As there exist a number of segment types, including custom-defined widgets on the web, it is impractical to identify every single type of a segment on any arbitrary web pages. Therefore, hashtag only focus on identify a fixed set of mostly commonly segment like search, filter, menu, etc. The user can instantly access the generated custom table of content from anywhere the web page using a defined modality, then select the desired skip links to directly shift focus to the corresponding desired segment to the web pages. Hashtag also enable user to customize the entries or skip links in the table of content, Specifically, the user can reorder the skip links in the table of content based on the preference, and also delete the skip links from the table of content. After skip links are generated, it will be sent back to the extension so that it can pop up on the browser. Now, This extension reuse the table of content previously generated by a user to pre-populate or bootstrap custom table of content for similar but previously unvisited websites, which reducing the user manual effort. For example, the custom table of content created for an Expedia web page is reused for the bootstrapping table of content for similar web pages in other travel websites such as Travelocity, Priceline, hotels, etc. However, Aztec validates each skip link of a previously generated table of content to check if they are applicable for the current web pages. To determine the similarity score between any two segments, this Aztec computes a cosine similarity matrix after encoding the text of each segment using the well-known Word2 vector encoding technique. The exact procedure of matching segment between two different versions of the same web pages, especially when the content of the web page is dependent on the web user search query. A user uses a screen reader and goes to the result is shown by using extension can easily navigate rather than traversing the whole page. A user can interact with Aztec table content interface by different modalities such as keyboard, mouse, and touchpad as indicated in here. While navigating the web page content, a user can use any of these actions listed to add a skip links for the currently focused segment in the table of content. The job is this modality is to navigate. To test the performance of our extension, we conduct a user study on 15 people by giving two tasks. First task is to buy a product from an online website. Second task was to book a hotel room from a travel website. The participant performed each of these tasks under the following these three study condition, and we check their completion time for the performance evaluation. The first condition was using the screen reader. In this case, the participant used only their preferred screen reader to compute the study test. Second test is using another technique is called SAIL, which employs a saliency model to determine key segments on the web pages and then automatically add area landmark to these segments so that user can use area related shortcuts to access this segment. And finally, final one is using our proposed solution. And the participant varied in age between 25 and 64 years. All the participants did not report any motor impairment that affected their ability to use screen reader shortcuts. All participants regularly access a variety of websites such as shopping, searching, etc. Our result was noticeable in compared to previously existed technique. For the first task, the average task time was with Aztec was 359.66, which was much lesser than with just using a screen reader, and as well as with the second technique, which is the SAIL. We also observed the same trend with the second task, where the average task time with Aztec was 419 seconds, which was much lesser than with just screen reader and with the SAIL. We did the Kruskal-Wallis test, which is a non-parametric method for the testing whether the sample originate from the same distribution. It is used for comparing two or more independent samples or equal or different sample sizes. The test score of completion time for first task was 33.28, whereas for the second task was 33.44. Throughout the experiment with the participant, we also noticed some choices among the participants. All the participants stated that they would like to using multiple choices for interacting with the Aztec. And 8 participants explained that they prefer to use pointing device to interact with Aztec. And 5 participants also use the keyboard to access the feature of the Aztec. Only 2 participants use more than one input modality to interact with the Aztec interface. 6 participants also desire a hierarchical management of skip links skip links in the table of content rather than the current linear list of arrangement. So let's quick recap our work. We presented a Aztec, a browser extension that enables blind screen reader user to efficiently and conveniently browse the web by creating their table of content for any arbitrary web pages. A user study with 15 blind participants showcased the effectiveness of Aztec, significantly improving web browsing efficiently and usability. However, during this time of experiment, we find two limitations. A user has to manually create the custom table of content from a newly visited website in case no previously generated table of content exists for similar kind of websites. Another limitation is that when the user rely on keyboard to interact with the Aztec, they always need to press the pass-through screen reader shortcut first before using any of these Aztec related shortcuts. One possible way to solve this by increasing familiarity with pointing device can be mitigate this problem. But these are the topic that we are working on. We are currently working on. So let's see a snippet of this work. In this video, I'll give a brief instruction on how Aztec can be used. As you know, screen readers. In this video, I'll give a brief instruction on how Aztec can be used. As you know, screen readers work linearly. Therefore, if you want to use a screen reader to a traveling website like Expedia to change any filter group, you need to traverse through each element by pressing a specific key from the keyboard and listening to each word that it announced. If you missed your expected button or group, you need to traverse it again to reach the same position. To use this Aztec, you need to press Ctrl-Shift-O from Windows, and if you are using it from Mac machine, then you have to press Command-Shift-O. After that, you can switch all the leads using the Tab button, and if you decided to choose an option, then press Enter to select, like what this video is showing.
Heading Level 4 Table of Contents. Link go to quote stops quote. Link go to quote airlines quote. Link go to quote departure time in Norfolk quote. Link go to quote arrival time in Newark quote. Link go to quote departure time in Norfolk quote. Enter.
Thank you. If you have a question, please, I will help you to answer. In this bit.
All right, thank you, Javadul. So before we get to the questions, I know Yasmin's got to leave in just a minute. I wanted to give her a chance to say hello to the group. Obviously, she's had a big impact on the work that Sean's doing. Yasmin, do you have a second to say hello to everyone?
Yes, hi everyone. I am Yasmin Nomani. Hi, it's really good to see you all. I won't take long. Sorry?
Keep going. That was the video looping in the background.
Oh, okay. So it's really good to see you. Thanks for Dr. Nelson and Dr. Weigel for organizing this great event. And I have been working with Dr. Nelson and Dr. Weigel on creating stories from archived collections during my PhD at Old Dominion. And then I have been a postdoctoral researcher at the University of California, Berkeley. I have worked for 2 years on some stuff related to reproducibility and software curation. I have done some work with the library and with the Berkeley of Data Science Institute related to this stuff. So I'm going to post here some like materials. I'm sorry, I posted the message and I thought that I'm going to do like Control Enter to like post the links. So I'm going to send the links now. I'm creating them. That have, you know, like most of the articles they have created during my time at Berkeley, and also the books, some really useful books that BIDS have created before I go there, and any other materials, and anyone, if you know, like have questions or have anything that I can do related to this issue, I would be happy to answer this later. I post also my email and my contacts, like for future reference. Yeah, that's it.
All right, thank you so much, Yasmin. Javadul, if we could jump back to you, the questions that we have. So Justin, I know you had a comment question.
Yeah, so it seems like one of the things that you're trying to do is, sorry, there's my intern in the background here. It seems like one of the things you're trying to do is exercise the UI components to try and figure out where to put the S tags, right? One of the things that Trevor Bostic and Jeff Stanley did at MITRE was develop the Demoticus framework, which basically takes my dissertation and exercising the UI components of web applications and tries to assess the accessibility. One thing they have not done is implement screen readers in that overall framework. So I think there's some mutually beneficial gaps here. I posted a link to a podcast they did, which gives a really succinct description of their work and the code base as well. And if I can make an introduction, let me know, but I'll kind of throw that into your court.
Okay, I will look into this. Okay.
All right, any other questions, comments for Javadul?
I have one. Okay.
Yeah, please.
Yeah, I noticed the most visual impact participants in your study are using either the laptop or the desktop. But nowadays, when you access the web services using your mobile phone, many web services have implemented a different version of with the different layout of the website. They implement the version to fit the browser in your phone with a very similar, like the linear layout for the website. So I think for many web applications, maybe before you achieve your own layout to reformat the web page, maybe the mobile version of the website can be facilitated to produce a very convenient version to fit your framework. Yeah, that's what my thought.
Sure.
Okay, so we don't sort of reformat the web page. It's more like a virtual layer on top, wherein we just analyze the web page and figure out what segments are there on it.
Yeah, I see that. But,
so basically, even if you feed a different, mobile layout, it's still going to, hopefully return the same because we're just doing some kind of semantic analysis of the web
yeah,
page.
probably I think if you extract some essential elements in the web page, it could be more easier.
Yeah. So
but I guess, yeah.
Yeah. And that's exactly what we're doing. Some of the very generic types that are typically found in many web pages, something like search results, right? The concept of search results is extremely common to many, e-commerce websites, right? And then these search results typically have a bunch of filters,
yeah,
right? And then there are sort options. Then there's a search form. There's always a menu in a web page, right? So we treat these as abstract entities and we just try to extract them from the, whatever current web page is, right? We instantiate them, you can say, at runtime, depending on which web page we are on. And then we just provide skip links to these important segments on demand. Basically, if a user, as they're using the screen reader and navigating over the web page, if they think that, okay, they have to, revisit this segment. Let's say when you're going over search results, right? You have filters and you have search results. You typically go back and forth, right? So if you want to avoid this kind of repeated key presses with screen readers, you might as well add these two segments to the table of contents, your own custom table of contents. So whenever you want, you just press a key, table of contents pops up, and then you just go access the segment there. The screen reader focus will be automatically shifted. So that's the idea. So basically the essence of this work is to reduce the amount of screen reading and getting the task done with fewer shortcut presses. Hopefully that cleared.
All right, thank you. Any further questions for Javadul? Or if not, I'll ask you to unshare your screen and we'll, so at this point, the idea is, so we've already heard from Frank at the very beginning. He had a class 2 o'clock. We've heard from Yasmin because we know she's got to go in a second. But I know we have a bunch of other alumni here, and it would be great if we could hear from them what they're up to and what they've done post ODU. So Justin, you want to go first since you had a comment about the previous presentation?
Yeah, sure thing. So I'm Justin Brunel. I finished my PhD in 2016 and have been working at the MITRE Corporation, which is a not-for-profit company that operates federally funded research and development centers, basically putting us somewhere in between a company and a national lab. And my position there is a principal researcher, and I'm responsible for guiding the research that comes out of the Software Engineering Innovation Center within MITRE Labs. So my research focus in recent years, I've already mentioned the work on web crawling to aid accessibility evaluations. I've done some work in corporate knowledge capture and intranet web archiving, and my most recent research efforts have been in implementing an infrastructure for archiving the dark web. So I know we're trying to make this a minute madness. I will refrain from further discussion, but really appreciate it. Really interesting talks. Thanks for allowing us to come crash the party.
Right, thanks, Justin. And of course, Justin, we still see him hanging around the halls of ODU when he shows up for football games and also does adjunct teaching for us as well. So, but we have another person on the line that you might not have heard of. So in Sean's work, he talks about the Al-Nomani algorithm, but also basing on Drew's work, we saw some pictures that go back to Ahmed Alsam, and we have Alsam summarization. So Ahmed, you want to say a few words? Did we lose Ahmed?
I'm sorry, I haven't gone yet, so I have to go. But Ahmed isn't. I think he has a meeting right now. So
okay, all right. Oh, sorry, I should have tried to get to him.
And Ahmed is my husband. That's why I'm answering instead of him.
Okay, all right. Thanks. So Matt made note of that. We'll let Matt go next with all summarization.
No. Okay, so I think I was part of coining that term with all summarization. So I'm Matt Kelly. I graduated from ODU, was still in 2019, so fairly recently. I immediately took a position at Drexel University in Philadelphia as an assistant professor, tenure track. I am still kind of researching some of the aspects of my dissertation research, which dealt with aggregating public and private web archives, so it dealt with privacy issues as well as a heavy thread of memento. Since then, I've basically been investigating stuff that's I'm trying to err more toward other people's work toward my own work. So I am in a school of information, not computer science now. So dealing with that sort of area, there's a lot to learn from them. But still coming as a computer scientist, I still have my own research agenda. So a lot of my recent research has been on dealing with aspects of personal identifiers, persistent identifiers, and historical ontologies, actually, which I never dealt with when I was at ODU, but then trying to do that and tie in a memento component to it. So we're still kind of investigating that and also shoehorning it into my own research, and there's still a lot to do.
All right, excellent. Thank you. So another person that we interact with regularly, Martin.
Hi, Martin. I graduated in 2011. I was number 3 with Dr. Nelson, and did a postdoc at Los Alamos National Laboratory for 3 years, and then via a detour at UCLA, went back to LANL. I'm a scientist there in the research library and team lead of the prototyping and development team. So that's not dissimilar to a faculty position, except for I don't have to teach, but I can teach. I don't have to get external money in, but I can. And beyond that, I do self-directed research with a small team of developers and students. I take bragging rights in having held the publication record for a long time, up until Justin dumped a whole bunch of preprints somewhere and therefore cheated the system and scored a little bit more than I did. But that's fine, you know. collaborative efforts lead to really good things, right? So we won the best paper award at JCL and TPDL, which is cool. So bragging rights there. And one more thing I want to say is that there is a solid, I think pipeline is the marketing term, between ODU and LANL. So we've had a number of ODU students, former students at LANL, myself being an example. Frank McCown spent some time at LANL in our group. Sean is a current member of my team and also a PhD student, right? So that's a good example. John Berlin spent a time at LANL. Muntabir spent a summer internship last year, if I recall correctly, right? And we're currently in the process of trying to trick both Yasid and Gavindaya into spending a summer internship with us this coming summer. So, there's good opportunities for summer internships ideally at some point again in the higher altitude desert of New Mexico.
All right. Thank you, Martin. Yes, and the other aspect, of course, you go out to New Mexico and get you hooked on green chilies. So. All right, let me see. Another face that we don't hear enough from is Hanny. How are you doing there, Hanny?
Hello. Hey, how are you guys? Hello, can you hear me?
Yes, we hear you. Yep.
Yes. Hi. How are you guys? Long time. I know yeah, I should be a better student and collaborator, but I apologize for that. My name is Hani, and I took a completely different route than Matt, Martin, Justin in this sense. Like I went directly to industry and stayed the course. So after I graduated in 2015, I worked actually in slightly different perspective in prediction of user intent in social media. And I stuck with the prediction part of machine learning throughout my career so far. I worked in Microsoft for 5 years, worked on multiple teams, and initially in Outlook, I built the entire, with my team, of course, yeah, with the recommendation system within Outlook. And after that, I went to Cortana, natural language processing, but still the prediction and modeling machine learning aspect. I took a stint in actually teaching in the University of Washington. But yeah, I'm taking a break this year, COVID and stuff, because I prefer to see my students. Yeah, and recently, like in the last year, I moved to Amazon. I'm a senior scientist there, and I have multiple projects, but I'm leading the effort in AWS marketing. It's slightly different perspective, but still, if you boil it down, the same machine learning prediction problem, but in the marketing attribution. So we have like a little over $1 billion industry and money spent in the marketing part for AWS services. We have like 171 different services like EC2, S3, blah, blah, blah. So essentially you want to figure out where this money go and what is the best utilization of it. So any small dent we do in the prediction, you're talking about millions and millions of dollars, which is quite awesome. And yeah, like collaborating other projects with other teams. I like to keep it fresh and jump from one aspect, one problem to another. So yeah, it's been fun.
And Hanny holds the title for the most interesting post-defense activity, where he drove his motorcycle cross country from Virginia to Washington State. And that took, what, 2 weeks, 1 week, 2 weeks?
It took 11 days exactly, and the best time ever. I've been like wanting to like redo it for the longest time, but work and stuff, family. But yeah, it's been a highlight. 6 years later, it's still a highlight.
Yeah. All right.
I'm restoring that motorcycle, so.
Oh, excellent.
So still, yeah.
So how's the Mustang coming?
Halfway done, which is great. Yeah, so yeah, so many projects in the house, so that took us, yeah, cyber.
All right, so let me see. I see that Mohammed joined us. That's a recent grad for us. Mohammed, how are things in Missouri? You're muted.
I'm
Mohammed,
sorry.
you're muted.
So I graduated in fall 2020. I was like the first student who defended his dissertation virtually in the department, I guess. So this is my second year at Columbia College. So also I took a different route. So I focus more on teaching, right? Unlike the other members. So I teach, like, for example, in the fall semester, I taught like introductory courses like programming in Python and C++ and compiler design for the and in this semester I'm teaching other courses, totally different courses like programming in Java and also advanced programming in the operating system and object-oriented analysis and design. So hopefully during the summer I will have more time to work on other tasks. And maybe focus more on my research during the summer. But I have been focusing more on teaching for my first year.
All right, thank you. And let me see, Sood is probably our most recent graduate, so everyone probably still knows Sood.
Yes.
There you are.
Hello everyone, Sood here. Yeah, if you don't know me, I'm still in Norfolk, not going anywhere until we have another round of tailgates with Justin and the whole gang, if I call him, right? When things are back to normal, whatever it is. I work for the Internet Archive, and Internet Archive has officially turned into a remote first organization, I think, a long time ago. So yeah, I'm still in Norfolk, in the proximity of ODU campus, and I work from here. My job there is to work for the Wayback Machine team and also work as a research liaison. So if there are any potential partnerships that we can see between researchers and Internet Archive that we can benefit from each other, or researchers can leverage our data or something like that. I'm the person to talk to. I can make those things work. Also, I also keep looking for people that we can hire to work for the Wayback Machine team, part-time, full-time, hourly rate, whatever, in whatever capacity we can, basically. So far, it looks like Justin has been more successful in coaching ODU students than I am. But yeah, the fight is on. Yeah, so keep thinking about ideas that any one of you can work with the data that Internet Archive has, and if there is any opportunity, talk to me, and we'll figure something out. Like, you know, what can we do together?
All right, excellent. Have I missed anyone here? I don't think so. Trying to keep
Alex, I did not see him in the group yet.
I'm sorry, who?
Alex.
No, I haven't seen him. I knew that he was going to have some conflict, but he was going to try and make it. But I don't think he's been here. So
yeah, he retweeted some of my tweets, but on this, but that was it.
Okay.
So.
All right. So yeah, Alexander Nwala is now a postdoc at Indiana University, and he graduated after Mohammed, but before Sood, in that period where we had like 3 or 4 defenses all in a row. So you know, some of you guys have been out for a while. Justin, Hanny, you know, you're in hiring positions.
I was gonna say, just to follow up on Saud's point, I was just gonna say we are hiring aggressively in AWS and Amazon. So if you're interested, if you are like graduating soon or something like that, send me your resume. I got you. And the good thing is you can actually start working remotely because of COVID, and so the transition will be much easier. So yeah.
Yeah, and unfortunately, I'm not a hiring man. Well, actually, fortunately, I proudly say that I've never been in a hiring position and stick to the technical research. But I do know who the hiring managers are, and so I know we've got a lot of former WSDL folks that are joining with MITRE or have joined with MITRE, working with Grant Atkins, who just wrapped up his master's a few years ago. So yeah, there's lots of opportunities, and because what I do is primarily research focused, a lot of the folks coming out of the group have the skill sets that we're looking for, understand what quality research looks like, what it feels like, what it is. So yeah, definitely if you're interested in doing something like that, send either Hanny, me, Martin, Matt, whoever an email.
And from Lionel's point of view, I think that the pipeline is strongest for students and postdocs at all, students at all levels. Right? Last year, for example, I had a high school student on my team, which was absolutely awesome. So I think that would be our focus, unless you know how to build a nuclear bomb, but you like that sort of stuff. But then that's not my domain.
Right. So yeah, and if you know how to do that, what are you doing hanging around with us, right? So speaking of joining, so Abigail and Drew have good news, and I don't think we've talked about that. Abigail, you want to talk about what you're about ready to do?
Yeah, can you guys hear me?
Yes.
Yeah, so I was hired at MITRE, so I'll be starting there June 1st, and I'm super excited about that. I can't wait.
All right, excellent. And
so Justin paid you how much to say this?
It's surprisingly low.
And Carlton Northern put in a good word. Also a master's graduate from here 10 or more years ago. I can't remember. He was unable to join us. But yeah, so MITRE is starting to pull ahead and snapping up the WSDL grants. But
we pay
Drew
better in Amazon.
Yeah. Drew is doing something completely different. He's headed off to arguably one of the coolest cities in America. Drew?
Yes, sorry, I was muted. Yeah, I have accepted a software engineering position at Cox Automotive. They're a sister company to Cox Communication, and the job is located in Austin, Texas. For the time being, I'll be working remote, but eventually I'll be relocating.
All right, excellent, thank you. So that's all that we had planned today. If anybody has some last words they'd like to say, any bits of wisdom to impart to?
Well, let me just pass along. Michael and I heard from Lola, and she said she wasn't going to be able to make it, but wanted to say hi to everybody. She was going to be on a flight, so I guess she's able to travel.
Yep. And let me see. Joan Smith sent an email and said she was going to try and stop by, but I don't think I've seen her show up. So I was hoping that she'd get to join us. So I think, yeah, having it in the middle of the day made it difficult for a lot of people. But I really appreciate you guys coming out for this and participating. We had 5 really excellent presentations, and really glad with the slides, the GitHub repos, and I'm going to be posting this video hopefully to YouTube, and it will be available for all for the people who couldn't make it. So unless you
Michael,
have
maybe one more statement real quick.
Yes, please.
So I assume I speak on behalf of everybody that I'd like to thank you and all faculty and the entire WSDL group to making this happen. This is absolutely awesome. Not only is this great to see a lot of familiar new faces, but also getting a good overview of what's going on. We've seen on the participant list, right, folks from all over the place logged in, which is absolutely incredible. So this sort of outreach pays off. Not necessarily always in tangible manners, but it does, and so that's really cool. Thanks for doing this.
Well, thank you so much, Martin. I really appreciate everyone showing up. And
so one quick note: next month is graduation ceremony for 2020 and 21 graduates. Muhammad is, I think, planning to come. I don't know about Alex yet. Perhaps I'll ask him. I don't know how it will go, but this time they are doing the commencement in the new shiny big stadium, not in the closed Ted Constant Hall. Yeah, we didn't see a lot of football matches in that stadium because when it was built soon after we had this pandemic, right? It perhaps is going to be inaugurated with our graduation ceremony.
All right. Good point. Good point. Yep. And I don't really have great memories from that football stadium, so we'll just skip right over that part.
I just want to say thank you very much for Michael for organizing this. I mean, before this event, I roughly know what the other people are doing in this group, but this event gave us some opportunity to know some more details on the research topics and techniques. And we also learned a lot from the suggestions and comments of the audiences. Thank you.
All right. Thank you. Thank you so much. All right. Thank you, guys.
All right. Bye-bye.
Bye-bye.
Bye.
Bye,
everyone.
Have a great day, guys. Bye. Thanks.